12,800 feet up in the Bolivian Andes, scattered across a windswept plateau where almost nothing grows, lies a pile of stone blocks so precisely cut that engineers who study them today still argue about how it was physically possible. When researchers recently ran Grok AI through the full engineering data behind Puma Punku's most famous stones, the H-shaped blocks with interior joints, drilled holes, and interlocking grooves so exact that a modern feeler gauge can barely slip between them. The model's answer wasn't a shrug, and it wasn't a wild theory either. It was a structural, material, and logistical breakdown so specific that it left the researchers staring at their screens because the explanation it offered was somehow both more grounded and more astonishing than the ancient astronaut theories that have dominated this topic for decades. Today, we're breaking down exactly what those H-blocks are, why their joints genuinely should not be possible according to the tools we assumed the builders had, and what Grok's analysis actually revealed once real data, real mineral hardness scores, and real 3D scans were put on the table instead of speculation. Stick around, because the seismic engineering reason behind these blocks, the part almost nobody talks about, is honestly the most impressive twist in the entire story. Let's establish exactly what we're looking at, because the scale of this precision is genuinely hard to grasp until you hear the numbers. Puma Punku sits right next to the much larger Tiwanaku complex in western Bolivia. In mainstream archaeology, based on radiocarbon dating pulled from organic material found in sealed construction layers, places the main building phase at roughly 536 to 600 CE, meaning these stones were cut and assembled around the same time the Byzantine Empire was expanding under Emperor Justinian on the other side of the planet. The H-blocks themselves are carved primarily from red sandstone in a much harder volcanic rock called andesite, and their defining feature is a stepped, almost architectural profile when viewed from above, resembling a capital letter H, with additional notches and grooves cut into the surface. Some of these blocks weigh over 130 tons. One measured example stretches 36 feet long, 16 feet wide, and 6 feet thick, and the nearest known quarry sits roughly 10 to 20 miles away, across terrain with a serious elevation gain and absolutely no trees for wooden rollers, since nothing grows at that altitude. But raw size isn't actually the mystery here. Plenty of ancient sites moved massive stones. What makes Puma Punku different, what makes engineers stop and stare, is the interior precision. The internal corners of these blocks are cut so sharply and the flat surfaces so smooth that from a distance they genuinely look machined rather than hand-carved, and the drilled holes running through sections of andesite are remarkably uniform in diameter from entrance to exit, a level of consistency that is difficult to achieve even with modern hand tools, let alone Bronze Age equipment. Now, here's where the real controversy begins. And it's the exact question Grok's analysis was built to untangle. Andesite is not a soft, forgiving stone. On the Mohs hardness scale, it sits high enough that cutting and drilling it with copper or bronze tools, the metals archaeologists know the Tiwanaku civilization actually possessed, would be an extraordinarily slow and difficult process, since copper is significantly softer than andesite itself and would dull almost immediately against it. For decades, this exact contradiction fueled a huge wave of alternative theories. Everything from the claim that the Tiwanaku people used some kind of lost sonic or vibrational cutting technology to the more extreme suggestion, popularized heavily by author Erich von Daniken back in 1968, and later amplified by television programs built entirely around ancient astronaut theories, that extraterrestrial visitors either built the site directly or provided the tools and techniques to make it possible. These theories spread fast precisely because the contradiction feels so genuine at first glance. Soft tools, plus hard stone, plus laser, sharp precision, really does look impossible on the surface, and it's exactly the kind of contradiction that generates millions of views without ever needing to check the actual archaeological literature. But when you feed Grok the complete data set, not just the finished blocks, but also the unfinished ones still sitting at the site mid-production, the picture changes substantially, and this is where the AI's breakdown really earns its reputation for being genuinely different from typical viral content. Several blocks at Puma Punku were never and they function almost like a frozen snapshot of the construction process itself, showing partially cut grooves, rough surfaces still bearing visible tool marks, and stepped stages of refinement moving from rough hewn to polished. Experimental archaeologists, most notably Jean-Pierre Protzen and Stella Nair, have physically recreated these exact surface finishes using nothing more advanced than stone pounders, harder rocks used to hammer and gradually wear down the softer andesite surface combined with wet sand abrasion, essentially using fine sand as a grinding compound the same way sandpaper works today. This is the same documented technique used extensively by the later Inca civilization. And when Protzen and Nair ran their experiments, they successfully reproduced comparable levels of precision, flat surfaces, sharp Internal angles and smooth polished finishes, using methods that required zero metal tools capable of matching andesite's hardness at all. The catch in Grok's analysis was careful to highlight this honestly rather than glossing over it, is that this process is brutally slow and demands exceptional skill, meaning the real explanation was never really about whether ancient humans could physically achieve this. Precision, since the evidence proves conclusively that they could, but about how a civilization organized the sheer scale of labor, time, and specialized craftsmanship required to produce so many nearly identical blocks across an entire construction project. That question of organization turns out to be the real heart of the mystery, and it's honestly the part of Grok's response that generated the most discussion. Because the blocks are not just precisely cut, they are remarkably standardized, meaning multiple H blocks across the site share extremely similar dimensions and interior angles, almost like they were produced from a shared measurement system or template rather than each mason simply eyeballing the design independently. Grok's breakdown pointed to this standardization as evidence of what researchers now call organizational sophistication rather than lost technology, essentially arguing that the Tiwanaku civilization had developed something functionally equivalent to a modern manufacturing standard. A repeatable measurement and quality control system passed between skilled workers, allowing dozens of blocks to be produced independently while still fitting together with interchangeable precision. That's a genuinely remarkable claim about pre-Columbian engineering capability, arguably more impressive than a vague appeal to alien technology, because it means this civilization solved a coordination and standardization problem that plenty of far more recent construction projects have struggled with. There's another detail that Grok's analysis spent real time on, and it directly explains why the blocks are shaped the way they are in the first place. Because the H shape and the interlocking grooves are not decorative choices, they serve a specific structural purpose. The Andes sit along one of the most seismically active regions on Earth, and Tiwanaku's builders were working in an area regularly subjected to earthquakes, strong enough to level poorly designed stone architecture. When engineers ran modern, structural simulations against the geometry of the H-blocks, they found that the interlocking design, sometimes described as dovetail jointing because the grooves widen internally rather than running perfectly parallel, actually distributes lateral stress across a structure far more effectively than a simple stacked wall would. In an earthquake, individual blocks can shift slightly within their interlocking grooves without the entire wall collapsing, essentially functioning as a built-in shock absorption system almost 400 years before anything resembling formal seismic engineering existed anywhere else in the world. Some blocks also show evidence of copper cramps, small metal clamps, poured OR fitted into carved channels connecting adjacent stones, adding another layer of reinforcement against exactly this kind of ground movement. Once you understand that context, the extreme precision of the joints stops looking like an aesthetic flex and starts looking like exactly what it almost certainly was: a deliberate, tested engineering solution for surviving earthquakes in one of the most seismically unstable regions these builders could have chosen to build in. Let's talk about transportation too, because moving stones weighing well over 100 tons across miles of high-altitude terrain without wheeled vehicles or draft animals capable of pulling that kind of load is its own separate engineering puzzle. The quarry sites believed to have supplied Puma Punku sandstone and andesite site a considerable distance away, and researchers modeling the regional terrain have proposed that the builders likely took advantage of seasonal wetland and swamp networks in the area, floating the heaviest stones on reinforced balsa reed rafts across shallow water routes wherever possible, then relying on engineered ramps packed with clay and reinforced pathways for the remaining overland stretches. This isn't pure speculation either, since related raft-based stone transport methods are well documented across multiple pre-Columbian Andean cultures, including later Inca engineering projects that faced remarkably similar logistical challenges, moving massive stone blocks through mountainous terrain without wheels, combine water transport where the landscape allowed it with coordinated human labor, wooden or stone rollers, and rope systems for the remaining distance, and the transportation puzzle, while still an enormous logistical achievement, stops requiring anything beyond organized human effort and a genuinely impressive understanding of the local terrain. If you're finding this kind of deep engineering breakdown interesting, go ahead and hit that like button. It genuinely helps this channel keep making videos like this one. There's a specific joint detail Grok's analysis spent considerable time unpacking, because it's the single feature most often cited as proof of impossible precision, and understanding it properly actually strengthens the human-made explanation rather than undermining it. Many of the H-block grooves are cut with what stonemasons call dovetail geometry, meaning the walls of the carved recess are not perfectly parallel, but instead angle slightly inward or outward, creating a joint that physically cannot slide apart in one direction, the way a simple straight-sided notch could. cutting a dovetail groove into hard andesite using stone pounding and sand. Abrasion is significantly harder than cutting a straight one because the mason has to maintain a consistent non-parallel angle across the entire depth of the cut while working entirely by eye and touch, checking the fit against the neighboring block repeatedly throughout the process. Grok's breakdown treated this specific detail as some of the strongest evidence for exceptional human skill rather than impossible technology, pointing out that dovetail joinery is a well-documented technique used independently across multiple ancient cultures, including sophisticated wood joinery in ancient China and stone masonry elsewhere in the Andes, precisely because builders across the ancient world independently discovered that non-parallel interlocking joints resist separation far better than straight ones. Far from being an anomaly, the presence of dovetail cuts at Puma Punku places it within a broader, well-understood tradition of structural engineering. Logic that shows up wherever ancient builders needed their joints to survive stress and movement over time. The drilled holes deserve their own separate breakdown too, because they're frequently cited online as the single most impossible feature at the entire site, supposedly requiring rotary power tools that simply did not exist in the ancient world. Close examination of these holes under magnification tells a more grounded story. Rather than being drilled in one continuous motion the way a modern power drill works, the internal walls of many Puma Punku holes show subtle stepped ridges and slight irregularities consistent with a technique called hollow reed or cane drilling, where a mason rotates a hollow reed or cane against the stone by hand or with a simple bow drill mechanism, continuously feeding wet sand into the cavity as an abrasive cutting medium while the reed itself never actually touches the stone directly, since the sand grains do the actual cutting work. This technique has been experimentally reproduced by researchers studying similar drilled holes found across multiple ancient Andean and Mesoamerican sites. And while it is undeniably slow, requiring hours of patient, repetitive labor to bore through hard andesite, it fully explains both the achievable precision and the subtle internal wall texture visible under close inspection, without requiring any tool more advanced than a stick, some sand, water, and an enormous amount of patience passed down through skilled craft specialists. It's worth pausing here to address the ancient astronaut framing directly, because Grok's response did exactly that when researchers pushed the model specifically on von Daniken's theories and their modern television successors. The core problem with the extraterrestrial explanation, according to the evidence Grok laid out, isn't just that it lacks direct proof, it's that it actually explains less than the human-made explanation does. An alien technology theory has no answer for why the unfinished blocks at the site show a clear, gradual progression from rough cut to polished, a progression you would not expect to see if the stones were being produced instantly by some advanced external process. It has no answer for why the joint geometry so precisely matches known seismic engineering logic, specific to this exact earthquake-prone region, a detail that only makes sense if the builders were solving a very local, very human problem. And it has no answer for why the copper cramping technique used to reinforce certain joints matches metallurgical methods already well documented elsewhere in Tiwanaku material culture, rather than introducing some unexplained foreign technology with no connection to the rest of the civilization's known toolkit. Every single piece of physical evidence at the site points toward continuity with known Tiwanaku craftsmanship, scaled up dramatically in ambition and precision, rather than toward a sudden unexplained technological leap with no cultural roots anywhere else in the archaeological record. None of this means every question about Puma Punku has been answered, and it's worth being honest about the genuine gaps that still frustrate researchers today, because pretending otherwise would be its own kind of dishonesty. Nobody has recovered a complete workshop site showing every stage of tool production and stone cutting side by side in one location, which means much of the reconstruction still relies on piecing together evidence scattered across unfinished blocks, tool marks, and comparative techniques borrowed from later, better documented cultures like the Inca. The exact chain of command, whether specialized full-time masons existed as a dedicated profession, or whether this labor was organized seasonally alongside farming work the way Egyptian pyramid construction eventually turned out to be, remains an open question without a definitive answer in the current archaeological record. And the sheer scale of coordinated effort required, cutting, transporting, and precisely fitting together this many enormous standardized blocks at over 12,000 feet of altitude, still represents an extraordinary logistical achievement regardless of which specific tools were used at each individual stage. Grok's analysis treated these remaining uncertainties honestly, framing Puma Punku not as a solved mystery with every detail buttoned up, but as a site where the most extreme, technology-defying claims have been substantially undermined by physical evidence, even while plenty of genuinely interesting engineering and organizational questions remain open for future research. Comparing Puma Punku to other precision engineering sites around the ancient world actually helps put its achievement into proper perspective too. The famous Inca stonework at sites like Sacsayhuaman near Cusco, built centuries later, shows remarkably similar interlocking precision using documented pounding and abrasion techniques passed down through generations of specialized masons, proving that this general approach to precision stonework was not a one-time fluke, but part of a broader Andean engineering tradition that persisted and evolved over hundreds of years. Ancient Egyptian granite. Work cut using dolerite pounding stones and copper tools reinforced with abrasive quartz sand follows a strikingly similar logic, despite happening on a completely different continent with no cultural connection whatsoever, suggesting that multiple ancient civilizations independently arrived at comparable stone shaping solutions simply because the physics of hard stone, soft tools, and abrasive sand leaves only so many viable paths forward. When you place Puma Punku within that wider global context of independently developed precision masonry traditions, rather than treating it as an isolated impossible anomaly, the site starts looking less like a violation of what ancient humans could achieve and more like a particularly extreme, particularly ambitious example of a stoneworking tradition that shows up in different forms all across the ancient world, wherever skilled, patient, well-organized labor met a civilization determined to build something that would outlast them. So what actually happened when Grok was asked to decode these joints? The response didn't dismiss the mystery, and it didn't lean on aliens either. It did something more valuable. It separated the parts of the Puma Punku story that are genuinely still debated from the parts that experimental archaeology has already conclusively demonstrated. The claim that stone pounding and sand abrasion could physically produce this level of precision is not theoretical anymore. It has been recreated by hand in controlled experiments. The claim that copper tools alone were used for every single stage of production is more contested, since some researchers believe softer preliminary shaping might have used copper or bronze. Implements before switching to harder stone tools for final precision work. Grok's breakdown was careful to flag this as an area where the evidence remains genuinely incomplete rather than settled fact. What it did confirm with much stronger confidence is the standardization angle, the idea that these blocks were produced according to a shared measurement system rather than independently, and the seismic engineering purpose behind the interlocking design, both of which are supported by physical evidence. You can measure directly on the stones themselves, rather than requiring speculation about lost civilizations or advanced outside intervention. It's also worth being honest about what remains genuinely unresolved here, because that's exactly the kind of nuance that separates a serious AI breakdown from typical clickbait content. Nobody has definitively proven every single tool and technique used at every stage of Puma Punku's construction, and the unfinished blocks at the site, while incredibly useful, only show us a partial window into the full production process rather than a complete step-by-step manual. The relationship between Puma Punku and the larger Tiwanaku complex a short distance away also remains genuinely debated among archaeologists, including questions about whether both sites were built during the exact same period or across different construction phases separated by generations. And there's still ongoing discussion about how a civilization without a formal written language, at least not one that survives in any readable form today, managed to communicate and enforce a standardized measurement system across multiple stonemasons working independently on different blocks. Grok's response treated these open questions honestly, distinguishing clearly between what experimental reconstruction has already proven possible and what remains an active area of archaeological investigation, rather than pretending every detail has already been neatly solved. What makes this story genuinely compelling, more compelling honestly than any alien intervention theory could ever be, is what it reveals about human capability when you actually dig into the real data instead of stopping at the surface level shock value of laser-sharp stone joints. The Tiwanaku civilization, working at a brutal altitude with no trees, no iron tools, and no wheeled vehicles, apparently developed a standardized measurement system, engineered specific joint geometry to survive earthquakes, and organized enough skilled labor to execute a stone-cutting process that experimental archaeologists have proven, hands-on, actually works using nothing more than harder rocks and wet sand. That combination of environmental hardship, structural ingenuity, and organizational sophistication is arguably a more impressive engineering story than any lost technology theory could offer, precisely because every piece of it is something we can watch replicated today using nothing more advanced than patience, skill, and the same materials the original builders had access to. The next time somebody tells you these joints simply should not be possible without outside help, you'll know the real answer involves seismic engineering, standardized craftsmanship, and generations of accumulated skill, which honestly might be the more remarkable story all along. If deep dives like this one into ancient engineering keep you hooked, make sure you're subscribed so you never miss the next mystery we break down. Thanks for watching, and we'll see you in the next video.